to say everything. So you've got to be able to envision this and draw this picture. Let's go through it. So here, to start off, a household aquarium tank in the shape of a rectangular prism. Okay, so I'm going to do my best drawing the rectangular prism. So here's a rectangular prism. Okay, more or less, okay? Okay, it has a base length of 24 inches. So let's say that that's the 24 inches. And a base width of 15 inches. So as you can see, I already switched up these dimensions. I'll switch them back because it looks like the longer side is along here. Okay, 15. And the height of the water to start is 12 above the base. So that means that if this is the water, this green stuff, imagine the green stuff being water, that this is 12, this height. So the height of the water is 12. Okay? Now, during cleaning, 900 cubic inches of water is removed. So now let's imagine there actually being some water that's removed. So imagine that the water goes down to this level, right? Then this red part would be the water that's removed. And that red part, okay, if I did this right, this red in here, okay, if I drew this accurately, right, this red part here should be 900 cubic inches of water. And they want us to find the change in the height. And it's tricky because they sort of give us useless information here. They give us this 12, which is useless because they want us to solve for the height, this length. So let me do it in a different color so maybe it's a little bit more clear. So they want us to solve for this length, right, from here to here, because that's the change in the height. That's what this last question is asking us. What is the absolute value of the change? The absolute value is just positive. And then they're talking about the change in the height. So the change in the height, you don't want it to be negative. You want to say like, oh, it changed 4 inches. It went down 4 inches, or whatever it be. So I just want to know what this height is, this change here. But I can do that easily because this volume, this red volume of water, I know how much was pumped out, right? During cleaning, 900 cubic inches. So this entire red volume of water is 900 cubic inches. And I also know, again, I'm looking for this pink height here, right? I also know the length of this volume. It's 24. And I know the width. The only thing I don't know is the height, h. So I know that the volume of a rectangular prism is length times width times height. I know that this water that was pumped out is in the shape of a rectangular prism, right? This water that's pumped out, the height, everything, when the water goes in, it comes into the shape of whatever it's put in, right? You put water in a teapot, the water becomes the teapot, right? You put water in a rectangular prism, the water becomes a rectangular prism. So the water here became a rectangular prism, right? This shape here, this it looks like this. It's a little bit more flat, right? Let's say. So here's the water that's being that was pumped out. Okay, so this is the water that's pumped out. And I know that this water is 900 cubic inches. And I know that this length here along the water is 24 inches, and that this one's 15. And what I want, and that's the trickiest part, you have to go through this and see that what you want is the height of this. Because that will be the change in the height of this water when it's pumped out, right? Because it's pulled out, and then the change in the height is just that h. So it's 24 times 15 times h is equal to 900, the volume. And you just solve for h by dividing by 24 times 15. Because 24 times 15 divided by 24 times 15 is 1. And I get h is equal to, I got to divide by 24 times 15 on this side. 900 divided by 24 times 15 is h. So let's see what that gives me. 900 divided by 24 times 15 is equal to 2.5. That's the change in the height.